Next question. The tolerance test is negative for the mannose, maltose, glucose, sucrose. So mannose is a uh, aldohexose, aldohexose, that is a monosaccharide, whereas maltose is a disaccharide. Glucose is a monosaccharide and it is also an aldohexose. And sucrose, this is also a disaccharide. Now here to solve this question we have to know uh, three things, that is what is tolerance reagent, the reducing sugar, and another is non-reducing sugar. So what is tolerance reagent? If silver nitrate, that is AgNO3, is dissolved in NaOH, if AgNO3 react with NaOH, then silver oxide precipitate will be formed plus NaNO3 plus H2O. This is not a balanced equation, and if NH3 is added into this solution, NH3, then Ag2O precipitates will dissolve and it will NH3, AgNH3 whole 2 NO3 plus NaOH will be formed. Now this compound, coordination compound AgNH3 whole 2 plus will participate in reaction. It is an oxidizing agent as silver is in +1 state, and it will oxidize the aldehyde group into carboxylic acid group. The general reaction is RCHO plus Ag NH3 whole 2 plus H2O, it will be RCOH plus Ag plus NH3 plus H plus, Ag. It will be metallic Ag and will get gray precipitate in this reaction. So here RCHO, it will oxidized to this carboxylic acid, and Ag plus, which will be reduced to silver. Now if there is a if a compound contain this aldehyde group, that is the formyl group, or if a compound contain this group, that is alpha hydroxy keto, then it will reduce the tolerance reagent into silver and it will get oxidized itself. So these compounds are reducing compound. Now sugar has all the aldohexose will have the aldehyde group, so all the monosaccharides which have free aldehyde group will be reducing sugar. Now between mannose and glucose, these are aldohexose and these are monosaccharides, so these two will be reducing sugar. So tolerance test is positive for these two. Now why this alpha hydroxy keto will give the tolerance test? Because it will undergo tautomerization. Here this hydrogen will undergo tautomerization to form an indiol intermediate and this indiol intermediate will further undergo tautomerization CHO to form a formyl group. Now it will undergo it will act as a reducing agent. So that's why the alpha hydroxy keto and the aldehyde group, the compound which have these two group will act as a reducing sugar. Now between these maltose and sucrose, these two are disaccharide, and maltose is a disaccharide of two glucose unit which has 1,4 connection, and the sucrose which is the disaccharide of glucose plus fructose, and here the glucose remains in alpha D glucopyranose form and the fructose remains in beta D fructofuranose form. We will draw the structure of this two disaccharide and will determine that whether these two will act as a reducing sugar or non-reducing sugar. This is alpha D glucopyranose, and if another molecule of alpha D glucopyranose react, this is first one carbon, this is anomeric carbon, so this is 1 2 3 4. In maltose there is a connection, glycosidic linkage will be formed with this C1 to C4 carbon. Glycosidic linkage means an ethyl linkage will be formed between these two hydroxyl group and one H2O molecule will be removed. So the product will be this is O, and here CH2OH, this is OH, this is OH, this is maltose. Now, as this C1 carbon, this will have hemiacetal form, that is it, as it is OH and this is an ethyl linkage, so this is a hemiacetal, and in presence of H2O it will be hydrolyzed to a formyl group, and this bond will cleave and it will be converted to a CHO group, and that's why the maltose will act as a reducing sugar, whereas the sucrose is alpha D glucopyranosyl beta D fructofuranoside, alpha D glucopyranosyl beta D fructofuranoside. That is, there will be a linkage between the alpha 2 anomeric carbon with alpha D glucopyranose, and the configuration of the second that is a fructose will have configuration beta, and the glycosidic linkage will occur between this anomeric carbon and with this anomeric carbon. We'll draw the structure. This is alpha D glucose, and when it react with that is beta D fructopyranoside. The configuration of beta D fructopyranoside is OH, here the CH2OH, OH on the above, OH in the below, CH2OH. This is, as OH is above the plane, so this is beta D fructopyranoside. This is beta D fructopyranoside. This is alpha D glucopyranoside. Now in fructose, there is a bond between this anomeric hydroxyl group, and this anomeric hydroxyl group. So one molecule of H2 will be removed and an glycosidic linkage will be formed. So the product will be, if we draw this glucose unit also in Howard projection, this is Howard projection formula. So we'll have the OH is below, this is O, this is below, this OH is above, this is below, this group is above, CH2OH, and it will be connected with this, that is one molecule of H2 will be removed. So we will have here a pyranoside ring is here. So this is an ether linkage, and this is also a glycosidic, this is also called a glycosidic linkage. And here, as you can see, that this carbon have acetal linkage, that is, this is also ether linkage and this is also an ether linkage. And for this anomeric carbon, this is also a ether linkage and this is also ether linkage. So this is quite stable and it will not hydrolyze into a formyl group. So this compound is a non-reducing sugar. This is a non-reducing sugar. So here this is fructose. This is fructose and this is a non-reducing sugar. So our question was, the tolerance test is negative for. So for non-reducing sugar, it is negative. For reducing sugar, it will positive. So sucrose is non-reducing sugar, so the answer will be sucrose. So guys, if you have any doubt regarding this video, please let me know in comment box.